Alright, here's another one. This is a big old fraction. Instead of just trying to do something fancy with it, we can manipulate it by dividing everything by x squared. So I'm going to divide everything by x squared to make them look a little nicer. So we have x to the first power plus 3x to the negative 1 power. Remember, you subtract the exponents when you divide like that. This would be x to the negative 2 power dx. Taking the integral with respect to x. So let's do the first term. We add 1 to the 1 and then we divide it by whatever you get, which is going to be 2. So it's going to be x squared divided by 2. The next one is kind of interesting. Check this out. If we add 1 to that, we get 0. And so it doesn't work. We can't just do the regular power rule for that one. So I'd like to have you guys recall when we would take the derivative of the natural log of x, we would get 1 over x. So if you were doing the antiderivative of 1 over x dx, you would go back to the natural log of x. But we do have to specify and make sure that we say it's the absolute value of x. In this situation, when you're given the problem, you're not going to get a negative in a natural log. You would assume that it would be positive because you're not allowed to have a negative in a natural log, because if you look at the graph of a natural log, it has an asymptote right here. There is no negative numbers in a natural log in its domain. So whenever you get 1 over x, we know that's going to be natural log of x. Now don't forget, 1 over x is the same as x to the negative 1. So if we get that, then we get that. So if we look back at our problem, I'm going to go ahead and write it on the side just because I think it'd be easier to see since it's the first time we're seeing it. If we're taking the integral of 3x to the negative 1 with respect to x, you could, I'm just doing this for visual purposes, you could take out the constant, the 3, and then since this is 1 over x, we can say this equals 3 times the natural log of the absolute value of x, and then you would add your c to it. So here we would have 3 natural log of the absolute value of x, and then the last term, when we add 1 to the negative 2, we would get a negative 1, so we have x to the negative 1, and we divide it by negative 1. So that's going to change my sign right there on the 4, and so now I'm going to get rid of that because divided by 1 doesn't do anything, and that's my answer. But don't forget the c. Here's the formal definition in the text. Antiderivative of 1 over x would give you natural log of x, the absolute value of x, and it specifies a domain, which is what I was talking about with the graph, and that's what you get. So it's a formula you can memorize. It's funny how they put the dx right there. That might confuse some of you. They're just you can take that dx and drop them right here, so it says 1 over x. It's just a notation thing.